All right, little interruption. So I'll be doing this in two parts. For part B, I'm adding my 0.88 grams of sodium hydroxide. So if I get into my beaker here and cross out what I can, my reaction becomes NH3 plus HOH. And then that gives me NH4 plus OH minus. Now, I'm going to go through and figure out how many moles I have of everything here and do my BCA table, because when you add stuff to a buffer, you have to figure out if it ends up as a buffer or not, because I have a starting number of moles, 0.022 moles of this. Actually, I wrote it backwards. It should be NH4 plus OH minus gives me NH3 and then water, because I'm adding my 0.0022 moles here, so it's going to be part of the reactant. So my NH4 starting number of moles was 0.072, and that was just by taking my grams and dividing it by the molar mass initially, and then 0.09 moles. Okay, so I have, let's see, my hydroxide is going to get used up first, so minus 0.022 gives me 0. It's my BCA table. Minus 0.022 gives me 0.05. Add 0.022 gives me 0.112. Okay, I've got partners, so it's a buffer, so I can plug it into my equation. Negative log of the Ka value, 5.56 times 10 to the negative 10, plus the log of my base, 0.112, over my acid, which was NH4, 0.050. That gives me a pH of 9.61. Okay, that was the first number 2. There was another number 2, which is the acid-base titration problem. I have 40 milliliters of 0.100 molar acetic acid. It's titrated with 0.150 molar NaOH. Ka is 1.8 times 10 to the negative 5. Okay, so if I'm adding hydroxide ions, then I'm going to have my acetic acid, HC2H3O2, adding hydroxides to it. Aqueous, all of these. Okay, it's going to give me my acetate ions and water. Okay, so I'm going to go through and I'm going to figure out millimoles of this stuff and figure out what I have left. So if I take my, I'm asked to solve for pH after adding different amounts. So my 40 times the 0.1 molar right here is going to give me my number of millimoles of acetic acid. So that's 4 millimoles. To get hydroxide, I need to take this concentration, 0.150, and multiply it by my different amounts. So I have, for part A, I'm adding 15 milliliters. So then I multiply those together, and that gives me 2.25 millimoles. Okay, this is 0. So my hydroxide gets used up first, and I end up with 1.75 millimoles here, and plus 2.25 gives me 2.25 millimoles right there. I have partners, so you plug it into the Henderson-Hasselbalch equation, which you guys can do. You get the pH is equal to 4.85. All right, for B, it is asking for the, what is it asking for? B is asking for the volume of sodium hydroxide used in the titration in order to reach the equivalence point. So at the equivalence point, you just need to know by definition that if you have 4 millimoles of acid, then you also need to have 4 millimoles of the base. Okay, so that means that I'm going to have 4 millimoles of sodium hydroxide. And I know the concentration is 0.15 molar. So 0.15 molar is equal to my number of millimoles over the volume in milliliters of the base. So then I just need to solve for that number. And you should get 26.67 milliliters. Okay. C then asks you what is the molar concentration of acetate ions at the equivalence point. Okay, if I'm at the equivalence point and I've got my acetic acid and my hydroxide ions and giving me acetate ions and water, if I start with 4 millimoles of this and 4 millimoles of this and 0 of this, then these are going to completely react and I'm going to end up with 4 millimoles of acetate ion. Then I just need to divide that by my total volume, which was the 40 milliliters of the acetic acid plus the 26.67 milliliters of the sodium hydroxide. So then you can just divide that out. You get a concentration of 0.060 molar. Which we need for part D. Okay, because D then asks you for what is the pH at that point. And if the concentration of acetate ions is equal to 0.06 molar, then I can go through and do the ice table for that, because that's all I have left. I don't have any hydroxide, I don't have any acetic acid, all I have is that. So I need to rewrite my equation to be my acetate ions plus water, giving me acetic acid plus hydroxide ions. And my starting concentration is 0.06 molar. Water doesn't matter. I have 0 of this to begin with, plus x minus x over here. Now, since I'm producing hydroxide ions over here, then it's a base, which means that I need to use the Kb value. So the Kb value, they gave us Ka, so I need to do my Kw over my Ka, which is 1.8 times 10 to the negative 5. So that gives me my Kb value, 5.56 times 10 to the negative 10. That equals x squared over 0.060 minus x. Okay, from there you guys can go ahead and solve for x. Be careful on this one. When you solve for x, it's your concentration of hydroxide ions. So that gives you 5.78 times 10 to the negative 6. So then your POH is 5.24. And then your pH then is 8.76. Okay, and that's at the equivalence point. So you should know that on a graph of pH, a pH curve for the weak acid, starting point's a little bit higher. The equivalence point is right there. If you followed that across, your pH would equal 8.76 right there at that point on your graph. Okay, that was D. E is, what is the pH after adding 40 milliliters? So if I again start with my original, because I'm adding sodium hydroxide, water doesn't matter. My millimoles, I'm starting with 4 millimoles of this. If I add 40 milliliters of sodium hydroxide, then that's 6 millimoles. Okay, so in this case, my acetic acid gets used up first. And I add 4 over here. Okay, what I'm left with here is 2 bases. And this is a strong base wins situation. And so I first need to figure out the concentration. If I have 2 millimoles over my concentration of hydroxide ions, 2 millimoles over my total volume. So I added 40 milliliters of NaOH to the 40 milliliters I already had. So together, that's 80 milliliters, gives me 0.025 molar of hydroxide. So then POH equals 1.6, pH equals 12.4. Okay, on to the KSP questions 3, 4, and 5. Number 3 gives you the KSP for magnesium fluoride is 8.0 times 10 to the negative 8. What is the molar solubility? So the molar solubility, if I write out the dissociation of that, I'd get magnesium ions to fluoride ions, and it would dissociate into S and 2S. My KSP is equal to my concentration of magnesium multiplied by my concentration of fluoride squared. So it would be S times 2S squared which is equal to 4S cubed, and I'm trying to solve for 8 times 10 to the negative 8 is my KSP. So solving for S gives me my molar solubility is 0.00271 molar. Number 4, we're asked to figure out if a precipitate will form. We've got 10 milliliters of 0.100 molar barium chloride, 40 milliliters of 0.0250 molar sodium sulfate. Okay, if this is double replacement reaction, the sodium and the chloride are going to react together. It's a double replacement. Those will be soluble. So my question is, will barium sulfate precipitate? Okay, what I need to do is go through and write out my dissociation for barium sulfate. This is solid, dissociating into barium ions and sulfate ions. I'm also given KSP for barium sulfate is 1.1 times 10 to the negative 10. If I write out my expression for QSP, which is calculated the same way you would calculate KSP, you just plug in actual values versus equilibrium values. So it would be my concentration of barium plus my concentration of sulfate, not plus, multiplied by, sorry. Now, in order to figure out these concentrations, I need to go through and do M1V1 equals M2V2. Why? Because I have the initial concentrations of each one. So for barium, the initial concentration is 0.1. Sulfate, the initial concentration is 0.02. But when I combine them all together, the volume changes. And so the concentration changes too. So if I plug in those numbers and solve for M2, let's see, for barium, 10 milliliters, is the volume, times my first molarity, 0.100, equals M2, times my V2 would be 50 milliliters. Okay, so M2 for barium is 0.02 molar. I would need to do the same thing over here to find sulfate. I would solve for M2 would give me 0.02 molar. Also, actually, turns out to be the same. That doesn't always happen. But then I can just go ahead and plug that in for my QSP, and I get 0.02 times 0.02. That equals 4 times 10 to the negative 4. Now, I want to compare that to my KSP up here, which my QSP is greater than KSP, and when that happens, then there will be a precipitate that forms. All right, last one is figuring out which precipitate will form first. I have, this is number 5, I have 0.1 molar of chloride ions. I've got 0.1 molar of chromate ions. And I add, and that's all in solution, the same solution, I add 0.1 molar of silver nitrate. Okay, so really I'm adding silver ions to this. I want to know, will silver chromate form first, or will silver chloride form first? So I've got to do calculations for both, and I'm going to go ahead and write out my dissociation. Silver Ag2CrO4. When that dissociates, I would get 2 silvers and 1 chromate. For silver chloride, I would get 1 silver, 1 chloride. And I'm going to go through and write out the KSP expressions for each one. For this one, I would have silver concentration squared times the chromate concentration. This one, I would have KSP equals silver concentration times the chloride ion concentration. Now I'm given these values, and I'm also given the KSP values. So what I want to go through and do is solve for the concentration of the silver ions. So here my KSP is 9.0 times 10 to the negative 12. That equals my silver ion concentration squared times 0.1. Solving for silver ion concentration gives me 9.5 times 10 to the negative 6. Okay, do the same thing over here, plugging in all my numbers. My KSP is 1.6 times 10 to the negative 10 equals my silver concentration multiplied by 0.10. My concentration of silver over here is 1.6 times 10 to the negative 9 molar. What this is telling me is how much silver I need in order to form a precipitate. Since this number is smaller, you're always looking for the smaller one, because that means that you need less silver in order to make this precipitate. So since it requires less silver to precipitate, then it will precipitate first. Okay, so my answer is AgCl. Okay, I'll be here on Thursday after school if you guys have any more questions, and then your test is on Friday.